Okay, it is 1 o'clock. So our goal today, to go out to today's canvas, is I can describe the effect of transformations on the absolute value function. And so you're going to get absolute value, and let me show you what that looks like. Here is an example of an absolute value function. They make the v, okay? Notice it is not a parabola, it doesn't make a u, it makes a v. And the way you get absolute value, and I'm using desmos.com, is if you type in ABS, that'll do absolute value. But what we're going to talk about today is as you change these numbers, stuff happens. If I change this to a -7, it moves over there. If I change it to a +1, it moves. So we call this transformations. And I want you to notice that the shape didn't change. It's still an absolute value, but you can make this skinny. Okay, see how skinny that got? Or I can make it really fat. Okay, that one got really, really wide. And so what happens as I change these values? And so that's what we're doing today. So we have some notes. So a translation is a transformation that shifts a graph vertically, that'd be what? Up and down, horizontally, or it could be both, without changing its shape. And then you could quickly graph absolute value functions by just transforming what we call the parent function. And in this case, the parent function is just regular old boring absolute value of x. And here's what that looks like. That's the parent function. And remember, absolute value says that whatever you have in here, you make positive, basically. So the absolute value of 0 is 0. The absolute value of 1, make 1 positive, is 1. The absolute value of 2 is 2. And on this side, the absolute value of -1, make -1 positive would be +1. Make -2 positive be +2. And we continue in that pattern. So what I want you to notice on here, that if it's a plus D, it shifts it up D units. And if it's a minus D, it shifts it down D units. So notice this is on the outside of the absolute value. This is on also the outside. So if it's plus, it goes up. If it's negative, it goes down. So let me go show you that. If I put absolute value x and then I type it in again, if I put +1, plus, it goes up. If I put -1, it goes down. That's all that's saying. See, letting someone in. Next, if it's inside, this is where kids get so confused. If it's inside the absolute value, this is when it goes left and right. Now, it makes sense that plus would go up, negative would go down. But when it's inside the function, negative actually makes it go to the right. And that's completely opposite than what most kids feel. If it's a plus, then it goes to the left. So let's go look at that, okay? So if I put this in parentheses, x -1, notice, here's the parent, it went 1 to the right. If I put x -2, it's gonna go 2 to the right. And notice, if I put a plus, it goes to the left. So inside the parentheses, it does the opposite of what most people think. So now we're going to analyze the effect, and I'm not going to do them all for you, but long story short, I'd say, okay, that's a +4, that's inside. So right here, we just said plus inside moves it to the left. So I would say left 4 units. And then for the 7, on the outside, the plus shifts it up d units. So I would say it's going to go up 7 units. You could also use the word, instead of shift, you could use the word translate. Translate also means shifting. Okay, but left 4, up 7. I believe you could do the other 3 yourself. I want to save our time for the more complicated things. So I'll let you finish those 3. Not only can you shift left and right, up and down, but you could also change the shape a little bit. Okay, so if you wanted to stretch it, you just make that number bigger than 1 that's in front. So if this number right here is bigger than 1, it stretches it. So if I put a 2 there, a 3 there, a 4 there, a 5 there, or even -1, -2, not -1, has to be bigger, -2, -3, -4, any number there that's bigger than 1, the absolute value of it, it's going to stretch it. So it's going to go from this and stretch it. If you make a number between 0 and 1, and ignore the absolute value, this is just basically saying ignore the negative sign. But whatever that number is, if it's bigger than 1, it stretches it. If it's between 0 and 1, it compresses. And then if it is a negative number, then we say it reflects across the x-axis. So let me go show you what that looks like. So we have our parent. There's our parent. So if I were to put absolute value of x, of course it's the same thing. If I put a number bigger than 1, like 1.1, it stretches. 1.2 stretches. 1.5 stretches. Anything bigger than 1 is going to stretch it. And the bigger that number, the more it stretches. Now, if I want to compress it, then I would use a fraction, or it doesn't have to be I guess it is a fraction, but yet you would use a number between 0 and 1. So like 0.99. Can't really see that very well. 0.75. Notice it compressed, it got wider. 0.4, see? 0.3, 0.2, 0.1. Okay, anything between 0 and 1 is going to make it wider, including the negative. All negative does is flip it over the x-axis. Okay, so you see that? It just flipped over. We call that a reflection. Okay, if I wanted to reflect the top one, see? It reflected. If I put this as a 4, and then that as a -4, reflected. All it does is it flips over the x-axis. So when I look at this number, I see that it's a 3. I go up here and I see that 3 is bigger than 1. So then analyze the effect, I would say it's a vertical stretch. Okay. Here, I see that I have a 2. 2 is bigger than 1. And again, you could just ignore the negative sign for now. So what does the 2 do? Bigger than 1? It also causes a vertical stretch by a factor of 2, some people say. And then the negative sign right here, thought I clicked that. The negative sign, remember, if it's negative, it reflects across the x. So then I would say, for that negative sign, reflects across the x-axis. So this had two things going on. The negative reflected, and then the 2 stretched it. I'll let you do number 7 yourself. Notice 3/4 is a number between 0 and 1, and you have a negative sign. All right, now they're going to piece a few of these together. So analyze the effect of the graph. So I'll pick number 11. And we'll go through them piece by piece. The first part, 1/2. What does 1/2 do? Well, 1/2 is between 0 and 1. And if you look up here, a little too high. If the number is between 0 and 1, it causes a vertical compression. So for this, I would say vertical compression. That's from the 1/2. Now, what does the +3 do? You may remember, if it's inside the absolute value, whatever this is, it does the opposite. So this is going to shift it, or you can use the word translate, 3 units to the left. If you had forgotten, if you go up here, you see if it's a plus, it moves it to the left if it's inside. See, mine's a plus, goes to the left. And then finally, what does -1 do? You should remember on the outside, if it's negative, it goes down, shifts it down 1 unit. If you forgot, you can read that above. So I would say shifts down 1 unit. Okay. So analyze the effect on the graph of the parent function. Pretty much you just need to talk about all 3 numbers, talk about the 1/2, talk about the 3, talk about the -1. Now notice up here, this has a negative sign that does something, a -8 and a 7. This one has a negative and a 3 and a -2 and a -5. So this one has 4 things happening to it. From the negative, from the 3, from the -2, and from the -5. And then this one only has 3 things, from the 2, from the +4, and then from the +9. But this one should have 4 things. All right, identify the attributes, complete the t-table, and graph. So we have something called a parent function, and that is the absolute value of x. The +1 shifts it 1 unit to the left. The -3 shifts 3 units down. And then what does the 2 do? This stretches it. Okay, and so if I were to draw this graph, where do I start? Well, normally I would start here, but I need to go 1 to the left and 3 units down. I need to start right there. I could do better than that. I need to start right there. Okay, I got that from here, -1, -3. Now from there, this is positive, so it's gonna open up. Okay, if that were negative, it'd look like this. And the 2, let's see, this 2 right here, you could kind of think of it as like your slope. So you're gonna go up 2 over 1, rise over 1, rise over 1, rise over 1. So you can think of this as 2 over 1. So you're gonna go up 2 over 1, up 2 over 1, up 2 over 1, and so on. Now, this is what we call the vertex. It's going to be the very bottom. You're also going to do the same thing on the other side, except now you're going to go to the left one. Okay, and you may notice now we have the absolute value. And this does continue forever. Just because we can't see it doesn't mean it doesn't. And so what is this vertex? The vertex would be -1, -3. And we're going to talk a lot about vertices in this class, mostly with parabolas, but that would be what's called a vertex. Now, I like to check my work. So I'm going to go type this into Desmos. Let's see, 2 ABS, x plus 1. I have to put that in parentheses. That's like the bars, basically. And then -3. Let's see, do they look the same? So this intersects about -2.5. Let me go look at mine. Ooh, -2.5. This one intersects at 0.5. Let me go look at mine. Looks to be about 0.5. Yeah, it looks pretty much the same to me. I mean, remember you can zoom in and out of there if you need to. All right, so identify the attributes, don't worry about completing a table. Number 13, I'll let you do that yourself. Remember the negative, and I'll do a quick drawing. The negative means it's going to look like that. Okay, so it's going to be pointed down. Okay, ours points up. So you have a negative, you have a 2, you have a 3, and you have a 4. What does it do? Don't be afraid to type it into Desmos to check your work. Please check your work. 14, I'll do 14 with you. Okay, so we start off. -1, so that means go to the right one. I like to spell this out. Okay, so we got 1/3. What does that do? It causes a compression. What does a -1 do? Moves to the right. What does a -5 do? Moves down. Okay. All right, now I got it. So starting from the center, the origin, I need to move 1 to the right and then 5 down. This is my vertex. All right. And then from there, you have this 1/3. You can think of it as rise over 1. So now I'm going to go up 1 over 3. 1, 2, 3. Up 1 over 3. Same thing, up 1 to the left 3. I almost had to check, make sure it wasn't negative. Okay. And then I draw my graph. See, so it starts here. And it really did cause a compression. This thing got pretty wide. And then over here. I have to check my work. Let me go type that in. 1/3 x minus 1 minus 5, especially being on a video. 1/3 absolute value x minus 1 minus 5. All right. Looky there, same thing. All right, now we got 2 more problems. 15, write an absolute value equation for each graph. So identify the vertex and the a value first. So now we're going from the graph to the equation. So let's think, okay. This, what happened? It looks like it moved to the 3 to the right, and it moved 2 down. So my vertex is 3, -2. And I forgot to put the vertex on this one. This vertex is 1, -5. Right here. So here, my vertex is 3, -2. What's my a value? It's kind of like your slope. So going from here to the next point, that would be the next point right there. So it looks like it's up 2 over 1, so that'd be 2. So for a value, I'd say 2. Now from there, yep, they're using y equals. You're going to be using F equals, but we could use Y. So let's see. We would have, I'm going to put it over here. You'd have Y is equal to, and this number goes first, so you put the 2 there. And then you got absolute value. And you're always going to have an X in here. And so this is what moves it left and right. You want to move it 3 to the right, so you're going to put -3. That's how you move it to the right. And then to move it down 2, you use -2. Okay. So why not check our work? Let me type this in and see if I get the same thing. And this goes over here, of course. 2x minus 3 minus 2. 2x minus 3 minus 2. Do they look the same? Crosses at 2 and 4. Mine crosses at 2 and 4. Vertex 3, -2. Their vertex 3, -2. All right, I feel good. So then number 16, I'll let you do number 16 yourself. Hint, this is going down. So I know it's going to be negative. And then you're going to have some number out front, and then absolute value X something, and then you'll have a number here. You'll have something here, here, and here. I'll let you do that one yourself. So other than that, I believe tomorrow is a work day, but that's all I have for today. So I'm going to go ahead and end the video right here when I'm saving.